So this, I think. Your laptop?
My lap.
Just mute.
No, my laptop's muted. The laptop's muted in the
Yeah.
Okay. So he's got his microphone, the phone's working.
Yes,
Yeah.
so it's
Yeah.
working now.
Yeah.
Yeah.
But we haven't changed it. Oh, okay.
No.
The audio has been working on, it's just the screen is not showing. The screen of the Zoom feed is not showing here, because previously.
So the point here is to start.
Sorry.
Is to sample a couple of times what the distribution across different sizes of regional centres. Because some of the regional centres are going to be really small. They're going to be 1 or 2% of the total. A few are going to be about 4, a few will be about 8, and as I said earlier, 3 will be about 20. So these are really big differences in scale.
Okay.
So in 2029, we're going to be looking at a total amount of disk storage of about 100 petabytes, which for reference is about the same as the WLCG Tier 1 Centre of RAL holds now the WLCG. And that ranges up from about a petabyte up to about 20 petabytes and an amount of scratch disk. But what we're going to assert then is that so long as sites are on about 50 gig connections, everything should be fine. Changes a little bit. And then when we go forward to 2035, now I've also included some early modelling of what we think the mean utilisation is going to be. And there we see again, you know, the small sites, the mean utilisation is not very much at all. You really have to get up to an 8 to 10% one before you get close to 100 gigabits. And then the large sites, the mean utilisation you expect to be maybe 150 on average. And so clearly, I'm asserting that we want at least twice that mean utilisation available. In practice, this is not an issue. The Rutherford laboratory, where we're going to be hosting 300 petabytes in 10 years' time, we are already on a 400 gig connection. That's just going to go on.
It's the 22% 1.6p, it's supposed to be 1.6p.
It is absolute. The scratch.
Yeah.
These are very hand wavy.
Okay.
I wouldn't pay too much attention. It probably should be. It probably should be upper end petabytes.
Yeah.
But also that's more complicated because it's more complicated. Yeah, and the scratch is really more to do with the compute resources than the storage. Yeah. But the story here is we do start getting up to some noticeable mean utilizations, but many sites already have those kinds of capabilities now. And the idea that between now and 2035 beyond, sure, everywhere has what they need seems unlikely. Now, one of the things about all of this, of course, is this all assumes not very much moving data around. This is, you know, recognize this again from WLCG, where they started out with this very, very strict model of the data gets moved out through the tier structure and then stays there. And that is not what happens in WLCG today. Data moves all over the place. And that happens largely because the network is there and the network is less of a constraint than storage. It's much, much easier to move stuff to move stuff to where you need it temporarily. And so I think in practice, even by 2035, I suspect we're going to be using more of the network than this because the network is going to be there to use. This is just another slicing of how this is showing some of the messy innards of our current model for the bandwidths. we've got a Jupyter notebook where you can plug in different assumptions, different amounts of total data. One of the things that's changed is changing, is the idea that the archival storage, the tape storage, is almost certainly only going to be at the larger regional centres, certainly at the 3 largest, then maybe at the 2 after that. But, you know, clearly, if somebody, you know, if a site only has, you know, 10 or 20 petabytes of data, the idea that we can run a tape service as well, unless they happen to already have one. So, one of the considerations there, well, actually, I'm going to get to that, so we'll pause that. So we've been doing some testing. So effectively, the way the SRC net is being developed is that it's going through phases. So this year we're at 0.1, where most of the testing is about basic data movement stuff. Can we move? There are 9 sites involved. There's about 8 petabytes in total. Slightly disturbingly, part of that is in the UK. And we've been testing moving moderately large amounts of data, 150 terabytes or so in a day, moderately large numbers of files. I think it was 1 million files in a day. Both of those tests went really well, and it demonstrates that the tools that we've adopted, which we've adopted from WSG Ruscio for the maintaining the namespace and FTS for running transfers, are perfectly capable of running in a different environment. Yeah, so actually I already said this, this was the large amount of data and the large number of files. And now the remaining tests are going to be around doing a complete ingestion workflow and then demonstrating that we can ingest data and display it as to computation on its own. And then next year, 0.2, there's going to be much more functional emphasis on the federated compute capabilities, and then 0.3, we start ramping up the data volumes and things. And what I think one of the side effects of the new science timeline is that we're probably going to do more work with precursor projects, so LOFAR and Meerkat are the really obvious ones. Some of the things that we've learned, some of it from the testing and some of it from the new timelines, as I say, mean network utilization is going to be much, much lower than originally foreseen for some time. I mean, it looks at the moment as though in the UK we're not going to need to invest in any more disk storage to meet the SRC net requirements. We might need to invest for other use cases, but as I said, for efficient transfers, we know that we want high bandwidths to be available. Things will just work better then. And then in internally federated SRCs like the UK, where we're going to have all of the data in one place, most in other places, obviously we're going to need to be able to move data efficiently, but we're very lucky we're connected by Janet, who are very good at doing that. But even the small SRC now, with only a few tens of petabytes of storage, will probably benefit on review of the link. But then again, by 2035, you know, that's and obviously that can be shared with other activities. But the mean utilization may well remain down around the time 5-10 years for really quite some time. But the UK, South Africa, and Australia, we're going to see it go much higher, particularly because of the demands of doing the tape storage. And as I said earlier, I am absolutely certain that we're going to see user and workflow transfers increasing. We haven't even started to model that, but unless something weird happens, the network will encourage that kind of behavior. So the placement model assumes 2 copies of each data center of different SRCs. In particular, ideally 2 copies on tape, as well as backups in the SDPs, which are the science data processors which are on the instrument side. But the model currently is looking at having the tape storage only at the larger SRCs. And two of these SRCs are right next to the SDPs in Australia. They're in the same data center. So you could say having two copies of the data center at the same data center is better than one. It doesn't really provide the kind of resilience you want. And that means that what you can see there is that's going to be a whole load of data going all the way to South Africa, which is almost certainly until some, there are investments that may help with this, but it is almost certainly going to mean data moving up through the global network. But again, volumes that probably wouldn't be able to deal with perfectly well. So as I said, almost everywhere we don't foresee problems, currently available bandwidths or existing plans. So the one place where we're not quite so sure is China, where because China is going to be a large SRC, it's going to be about 9%, which means it's going to be 90 to maybe a bit more, maybe more like 120 or 30 petabytes of storage by 2035. Mean bandwidth utilization is about 40 to 100. So ideally, it's going to have at least 100 gigabits available by then. Now, at the moment, they have a share, I believe, of 10. Now, there is a link that supports the WLCG Tier 1 in Beijing to Singapore, which is 100 gigabits. What I'm really interested to know, I'm not expecting anybody in the room at the moment to be able to tell me, is if the plan is to share that and then work out how to route things so that you can do that and then have that grow, or what the plan is. So this would be a really good thing to have a discussion about maybe afterwards, because I have no doubt that it's solvable, but it's only going to be solved if we sit down and look at it and talk about it. And clearly sharing between communities like WLCG and SRC there is the right thing to do where we can, and that's what's going to happen in lots of places. So the summary: data volumes and bandwidths. So it's refining its roadmap. It's still shifting a little bit. Those volumes in 29 and 35 just shifted by a year just in the last week or two. We can translate that to local bandwidth requirements, which in turn gives us an idea of what people need to be ensuring that they have. And as I said, the new estimates are much lower than previous ones. So the onus is on the sites to talk to their endpoints. Nobody else is going to ensure that they have network. We're going to talk about it, this group is going to make sure that it broadly works. But, ultimately, if you need bandwidth into your site, just as if you need compute, you have to talk to somebody about providing it for you. But we're confident that the NRENs are going to have the backing links that I think they pretty much already have. As I said, we've done some successful initial data movement tests, and we're going to be ramping those up over the next few years. We're going to be shaping out network and storage configuration issues, and we are going to have to optimize throughput. So one of the things in WLCG is they've steadfastly in the last 20 years not really focused on the way they get their bandwidth, they get their throughput is by throwing loads and loads and loads of connections at it, and that is not going to work for WLCG, and it's also not going to work for us. So there's an interesting bit of work there that we can work on together about optimizing that. Really important bit of work. There'll be some tuning. I'm sure there are people who love to get stuck into that. And then the last bit is about the coordination. So we have this strategy group that effectively is a mailing list. If you're involved in these discussions or would like to be, and you're not on the list already, you'll know because I've been sending emails to it. I hope they'll be going out. I get replies from some people, so I believe it was. Talk to me. And as I said, I think we're going to focus on face-to-face meetings a few times a year at the kinds of meetings that some portion go to. We're not going to try and get everybody in the same room, that's work. But we should be able to, here get a representative number. TNC certainly we get a representative number, and well, we'll see what happens with Internet 2. And then the other thing is that we're going to continue to collaborate with WLCG. We've had two now, APAN and APAN60 meeting where we've had a half day dedicated to the SKA network challenges. And it's clear every time we do that, the areas where we have shared interests. And we do not want to duplicate the good work that WLCG is doing. We might even be able to contribute to it, which would be good for everyone. So that's what I prepared. Did anybody have questions, comments? It's also clear and, you know, or it's after lunch or. So I'm going to, the question I'm going to throw out, who here is from a country that is participating? You may not be directly involved, but you might be from a country who's participating. Some people reluctant to own up.
I'm not sure.
Or not sure, yeah. Okay. And obviously there are countries who are, you know, we for example expect that our colleagues in the United States have expressed willingness to help facilitate things, and I think that's one of the reasons for throwing that fairly widely with this strategy group, is to make sure we have the people who they may not be members of SKA or directly involved, but they're part of the global network, and you know, in a position to help facilitate. So, as I said, that's what I had to say. No questions? In which case, Lars, I'm going to hand over to you.
Right? Unshare.
I will unshare.
I'll come up in a minute.
Oh,
That's okay, all right.
oh. Whilst I was just getting ready. Oh, yeah. He's ready.
All right.
Okay.
Should
You could see the letter. And,
Yep. All right, thanks. So I'm Lars Fischer. I am with NoGenet. I do international relations at NoGenet. I've been around this community for many, many years. As Ian mentioned before, I've been involved in designing and arguing about and figuring out how to do the networking for LHC and many other science projects. So one of the things I do is at NoGenet is I engage with large research communities, research projects. I have people like Ian who are doing an effort for a research project, a research community, come to me and say, look, we're producing all this data in Australia and South Africa, and we want the data to end up in China and the UK. What do we do? How do we make that work, right? And for these global efforts, it used to be very complicated because the networks weren't big enough, so we had to design special things. And I think my message here, if you don't want to listen to my slides here, is that isn't the case anymore. The networks have really grown, and there's been some concerted effort by a lot of networks coming together to design something global that really can work seamlessly together and take on these very, very large things. As Ian said before, it doesn't mean that there's not work to be done, because just because we know how to get the data from Australia to Hong Kong doesn't mean it gets to the site of the researcher. The researcher still needs to get the data from Hong Kong or London to their research center in Reading or Manchester or Beijing or wherever it is. So there's still work to be done, but we have made enormous progress in designing what we now speak of as the Global Research and Education Network, which isn't a single network operated by a single thing. It's not like Norginet or CERNet being a single network. It's more of a metaphor for all of us working together with all our engines coming together and virtually pretending to have a single network to serve science. So, science is global. And there are all these instruments being deployed around the world, like I put here CERN and I put the two SKA instances. And it's an example of the thing where science more and more move towards, instead of having an instrument in Korea and an instrument in Denmark doing things, they built one single instrument that is big enough to do the next generation of science they want to do. And they can only build one in the world because they can't afford to build one in each country. SKA is too big for that. And so our job at the NREMS is to find a way to get the data from where they decided to build the instrument, the LHC for CERN, and get the data to the physicists working with the data wherever they are. So we have to lower the barriers so the scientists can just think about doing their science and all this stuff about transporting and storing and whatever the data, we will just take care of that. So the GREN is our answer to making sure that that works, right? The Global Research Network. Historically, when I won't talk about when I started this community, that's too long, but 10 years ago, Andrew and I can talk about when we started this community. 10 years ago, doing this on a continent, doing it in Europe, doing it in the US was okay. We knew how to do that because we had fairly big continental networks. But once there was an ocean, there was something about very expensive subsea cables, was getting to that other ocean was really hard and the capacity was limited and it was difficult to do. And so we had to either ask the scientists to aggregate per continent or build very special and very expensive things to get to another continent, right? So here in Asia, to get from Japan to Australia would be very, very expensive, while doing things in Japan or doing things in Australia would be comparatively much cheaper. And I find when I talk to science communities, that memory lingers. Everybody remembers that was a problem. So people still think about, oh, if we have to do long distance, like going from Australia to the UK, we probably have to do something very, very special and build our own network and buy our own links. And part of the message here is, it's not the case anymore. That's not how it works anymore. We have actually built the things that can do that. Our mission is to make sure the network is where it's needed and when it's needed. That's what NREMS are for. We are here to make sure when science needs networking, we will deliver it to it. And we need to come together to organize ourselves so that we can act quickly and respond when science communities need something that is out of the ordinary, like SKA. And when I say act quickly, we have to act as quickly as a scientist. And as Ian explained about SKA, building instruments like that isn't something that happens overnight. It takes 10 years or 15 years. We have usually time to talk to them about what is it they're doing and what they need. But we have to do that outlook and planning and testing. And that's why we come to things like APAN conferences, right? We come here together to talk about how are we planning with these next generation things. And also we do try to experiment, find new technologies to lower the barriers for building these things. So an example of what we're doing when we come together is that we realized, some of us, that it was super expensive, for example, for my network, Norginet, to have good capacity to Hong Kong. We had very strict use case where we had to have reliable connectivity from Stockholm, from Sweden to Hong Kong. So we bought our own 1 gig link, with 2 of them for resilient and all of that. It was super expensive and not very reliable. And we realized there were lots of other networks. Shang had a link. There were people from Netherlands who needed a link. There were people from Singapore or from Japan or from Korea who also had links to Europe and so on. So there was all these small individual links. And we agreed to do 2 things. We agreed to some of us team together, and instead of me using the money I could afford to buy a 10 gig link, and Singeren using the money they could afford to buy, I think, a 10 gig link, and Arnet using the money they could afford to buy a 10 gig link. We put out all that money in a single pot and bought a 100 gig link. That allowed us to do much more with the same money and get a much better link. And then we did one thing more, because various groups were buying links. So there's, as you can see here, there's a Signet has a link between Japan and Europe. Kisti has a link between Korea and Europe. Some of us pooled and bought a link between London and Singapore, and so on. There's a couple of Saudi Arabian links that goes from Singapore to Saudi Arabia and from Saudi Arabia to Europe. So we made also agreements like the MOUs we saw being signed in the opening ceremony between the owners of those links, saying, if my link fails, you will provide me backup. And if your link fails, I will provide you backup. That way, it's feasible for Nordnet and Singeren to own a single 100 gig and invest all our money. Certainly, in a sense, we put all our eggs in one basket. Because if that single link fails, Signet will graciously, on their link, provide us backup, or the Saudi Arabians or whoever it is will provide us backup on their links. And so together, we now have a system of links that work together and back up each other of about a terabit across all these links between Asia and Europe. So suddenly there's enormous amounts of capacity. And now if you think about what SKA is asking about, of traffic coming from Australia into Singapore, maybe it becomes 100 gig, maybe it becomes 200 gig, but still, even today on the terabit system, it's not that much. It's not going to eat it away. The capacity is actually there. If it was just Nordnet who had to provide it, we wouldn't have that link. Singeren wouldn't have that link. Sham wouldn't have that link, but together we have it. So we have built this system that works together between all these partners that can do that. And of course, once we get to 2030, when they say they're going to hit this is not going to be 1 terabit, it's going to be 10 terabit. There will be ample capacity for doing this thing. So we found a new way of working between the continents, of bridging the continent divide and doing that. So this model has been very successful. One of the advantages also, and Simon can tell you a lot about that, is that it turns out that some of these links going between Singapore and Europe are a little fraught in this area here that is full of conflict and things go a little badly there. So we've had a lot of cable breaks, more than I would have expected on all those routes. But because there are 10 partners in here with each of 1 or 2 links, even when 2 or 3 links are down, the whole traffic still flows. It all works. Right? We can all survive that one link, another link go away. So in addition to having plenty capacity to go around for big science projects, we also have this guarantee that we have far more resilience than any one network could buy. Because even very big and very rich networks like Sham, for example, they couldn't buy 10 links. They could maybe buy 2, but they can't buy 10. So we get also far more resilience. So this model has been replicated at a smaller scale inside Asia, because as you saw these links, a lot of this gets to Singapore. And then there is this ring between Tokyo, Hong Kong, and Singapore to distribute the traffic, and the similar ring in Europe that distributes it. But there's been a separate MOU signed between some Asian partners from China, Korea, Singapore, and Japan and Hong Kong to have a separate network that distributes traffic that comes in between different parties here. So there is this backbone between these Asian partners to distribute traffic between those other. So there are this provides us landing points for things like the AR ring to land on and distribute the traffic between the main sites. And this is also given the basis for building other things that also land on that, right? So this means now that when we look at ARNet, it's of course providing the connectivity from the SKA site, which is down here. The traffic primarily will come up to Singapore. But then because it lands in a place that has both connectivity within Asia and has this ring that goes into Europe, it's easy to get the traffic out. And as we will see in a short moment, there's also opportunities for getting not just Australian on its own link to the US, but also getting to North America on a separate system, because the idea that the AER is built on has been replicated in something called the EcoNet. So there's a similar construct across the Pacific that again works between South Asian networks and North American networks, and then all of them have some number of 100 gigs across the Pacific. And again, they work together, so there is far more resilience and far more capacity. So again, when the traffic from SKA here in not here, only 1,000 kilometers from
A bit further up.
yeah, has to go to North America, there's all kinds of opportunities and routes for getting there. So again, we have that capacity, and again, this is about a terabit, I think, at the moment across the Pacific. But again, there's lots of capacity for doing that. And again, these links land on huge backbone links provided by some of the bigger immigrants in the area, so we can distribute the traffic among them. So there's really good opportunity for both doing the intercontinental traffic and for distributing it in this region, right? But it still, of course, means those points where these links end is not where the scientists are. So there's still a challenge with individual networks, right? If I've seen it site in Korea or India or China, the traffic still has to get from one of these big landing points, which are typically open exchanges, to where the scientists are. So similar in the South Atlantic, there is a collaboration between the South African Emirates and Europeans who have links from Lisbon down to Brazil. South Africans also have links over to Brazil, and North Americans who have links from Florida down through South America, and Red Clara, who has a ring around South America. So again, traffic from Cape Town, which is the closest big point to the SKA site in South Africa, has routes up to Europe and also across to North America. You will note that there are no good routes at the moment from here to Asia. The only route from here to Asia is up to Europe and back down to Singapore. So Sunrun and TNet, the two networks in South Africa, were tasked with doing that, have these routes already in place to North America and to the UK and Amsterdam, and are working on also ensuring that they have bandwidth going the other way around. What we are missing is the links that go from here across to Asia. But maybe when Blue Raman happens, over the next couple of years, there will be links from Djibouti here over to Mumbai. So maybe that's the start of having the traffic flow directly across and not having to go to Europe and back. But again, the pointer is there's ample capacity to make sure that happens. We don't have to, for SKA, build something special. So just for completeness, there's a similar system like this in the North Atlantic. The partners are Norginet and Surfnet and Sham. On the European side, it's Canary, ESNet, and Internet2 on the North American side. And then also two Asian networks who have rings around the globe, Cynet and Kisti, also actually have links across the Atlantic that are part of this. So again, I think currently there's provision 3.1 terabits of capacity between here. So again, the SKA traffic, even if it wants to move back and forth between Europe and Canada a couple of times, it's a drop in the ocean. Nobody will notice that going on. But it really, there is lots and lots of capacity. So putting all that together, I think for me, the main message here is distributing the network around the globe. Yes, we have to make sure that we operate and continue to collaborate as Emirates about this. But scientists shouldn't worry about having this happen. What scientists should worry about, if you're a scientist near Perth with an instrument that is going to produce a couple of 100 gigabits of traffic on it, might want to learn about it. So Andrew needs to know And maybe Andrew will come back from his management with a contract saying, you need to sign here and pay a special fee because it doesn't cover your normal university fee because you're sending far more international traffic, so it might be an extra cost. But other than that, they don't need to have their own link from Perth to London, anything like that. That will just work, right? The network is there and can handle this traffic. What we need to worry about is once the traffic gets to, for example, Hong Kong, how does it get to the Chinese SKA resource center? How does it get to the Indian SKA resource center? How does it get to a center that might be in Korea? That is where we need to worry. That is what we need to work on. The global distribution actually is a solved problem. We know how to do this. So, thank you. Questions, comments?
Yeah, I want to share I didn't prepare the presentation, but I will share the situation in Korea.
Can you get a microphone so everybody can hear you?
Yeah.
Yes.
So the situation in Korea. We trying to be learning network with SKA personality. So now we are referring for the next district. The whole thing is major responsible is Korea Aerospace Administration. That is the Korea version of NASA. We call it NASA. Yeah. I'm involved in the as an advisor to how to build up our data center and network for the SKA. Just in this year, we started to the frame project to how to build and how it is we can build up. Just to do that, that's only we can check that is already mentioned. Korea is provided maybe 3 or 4% of the whole scale resources we need to share. So that is one that the mission we should do. Just one the question and one thing is to share about is what I remember is when we build up the Southern OSC, so many campaign was done. You asking the citizen for the storage and network and the campaign device. And maybe SKA already do the can already give the several campaign device all about it. But maybe I don't know, you get the name for that. But that kind of information is not sure that our people.
Yeah, I confess I don't, at the moment, there is nobody from Korea involved in the network. But Korea is only 1.6% contributor.
Yeah.
So we could, I mean, of course, there's nothing that says that you can't contribute at a higher rate.
Yeah.
But if you just contribute in proportion, you know, even by 2030, 2035, that's still only going to be sort of 25 petabytes of storage. It's still only going to be, you know, maybe 20 gigabits a second. And I would imagine that's going to be easy to accommodate. But it depends a little bit exactly where it goes.
And I did not different from our own, but they said if they have the more resources already, they want to do their engage the board they want to go even more up to the more than the most
Yeah.
And the other one is in Korea government with the important thing is how many our scientists were enjoying this research. That is what because depending on the happening, our government can give us that one. So this is so we are trying to which organization, which research and go with
So you touch on an important question, which is that for most countries, their investment in SKA in some way correlates to their assessment of how much science they think, you know, which is going to be in some way related to how many astronomers have, you know, how big your astronomy community is. So I'm guessing that fairly small contribution means that somebody thinks you don't have that many, but enough that it's worth doing something. But of course, there's no reason why a country couldn't decide to contribute more. I mean, and I think the countries where that's not true, of course, is South Africa and Australia. Now, for both of them, this generates huge inward investment, so it's worth it for that. But also in South Africa, I know that they have a real ambition to build radio astronomy in the whole region. So they have a long list of countries that are not members, but interested in development. So yeah, we can't solve the problems of how you get your government to decide to invest, but I think that at the level that would be expected for South Korea, it ought to be really manned, because you have 10 years to invest, and the amount is not that much. It's still real resources.
Yeah.
You mentioned that what we did for the receipts, right? I think it's also important here to realise that, I think you also mentioned that we talked about the SKA organisation is building the software stacks just to serve as software that gets developed. It is really for the tier 1 sites, right? Locally, SKA resource centers. No. To deploy the hardware, storage and whereas a lot of the software is going to be standard packages and use of the elements. Yeah, to the distribution of the using the see the standard software, multiple software, all of that. And again, with the businesses that are starting to do that, they're testing those software packages with a few of the early adopters case. So that's on Korea is really one model. You should adopt that thing, and hopefully there will always be number of also for SLC. They have running for a couple of years.
So I think especially for the small countries, sitting back and letting everybody else sort it out makes lots of sense. It's just a smart thing to do.
Yeah, it's actually it's an era for the project. So if we shared out the details we this year and after we included the in the size like this is money we have that as an efficiency and
state. So question, do you know where the SRC going because it's actually it's a lot easier, right?
There is a very complicated because it's so particular there in but just as a comment down to the besides there's so Korea actually research issue. There are building the new already the AI data. Maybe that project just decided that so you can either with the but it's a pragmatic.
Yeah. Can have lots of things. Don't.
Do we have anybody in the room to speak about China?
Would you like to say something about would you like to say something about whatever you can say about China? I know that you can talk about CERNET side of things.
Actually, the CERNET is not involved in the SKA, even for the aerospace, but we are ready to provide support for the I know Because I know, for example, for the Shanghai operate of, I know they should have interconnection with the CTNet.
Yes,
And then CTNet have the, I just heard about they use the WLCG, that means, but I'm not sure, because that should be their VPN, right? Or how can they transfer the SKA traffic to the LC1, their VPN? I'm not sure. But anyway, I believe they just, because SafeNet, have their own 100 link, from Beijing to Hong Kong and then to Singapore. So they can provide the transit support for them. But just, just several weeks ago, we also discussed with CityNet, and I got to know that, for their 100 link, there might be the utilization just a little higher, so maybe they can just try to provide some limit-based support on them. And for Cernet, first thing, although we have no interconnection with Shanghai observation, but for our platform, we are under the upgrade to 400G, and we can solve the last mile issue.
Yeah.
Maybe we can work together with CityNet to provide more support for the SKA.
one question, so, the WLCG, of course, there's not only the tier 1 in Beijing, but there's also the tier 2, which I don't remember where it is now. Do you provide the connection for that? Or is that also CST net?
You mean for the interconnection?
Yeah.
Yes, we have interconnection.
Yeah.
With CityNet, in Beijing, but so far just 200, 20G. But just for because that's just for the local loop, we can upgrade without much issues. And you are talking about the tier 2. As I know,
Tier 2, I'm just gonna look up where it
that
is.
should be Lanzhou University, right?
Yes,
Oh,
yes.
Yeah.
Yeah, so is that, do you provide those links?
Yes, Lanzhou,
Yeah.
yeah, but no. Actually, because I just attend the LC meeting in Qingdao just last year, and I got to know the Lanzhou University just run maybe 2G from the telco provider
Okay.
with help from CityNet, but the bandwidth kind of low. But Lanzhou University is one of the top in for the Cernet. So I think that should be quite easy for us to provide the hand bandwidth support. But because LC1, the layer 3 VPN has not been implemented to the Lanzhou. It's quite complicated.
Yeah,
Maybe there's some lag inside the package in water. They can, they have the requirement to the LC1, but for the country network, they have their policy, they can not provide direct support. So that's why we are working together, try to find a way. Now, as I know, we are trying to find some way to provide support.
Yeah.
Support with their kind of network, but it's still underway. But anyway, I think Cernet is really provides support on it. And we are also now preparing a procurement for the 100 between Hong Kong and Europe. So maybe later we can also try to share some bandwidth. Together with CityNet, like from so the SKA and LC1.
sounds like we need to talk to CSTs.
Yeah.
Okay,
So thank you.
yeah, thank you, that's really helpful.
I didn't go. I haven't.
So,
Yeah.
any more questions, comments?
Student. But
I am Professor William from NAOJ project. So maybe one of the SKA
schemes are going.
NAOJ, and also on the other hand, I'm charging for the arena part and also the CG inside the Japanese group. So if something happens in around Japan or this other states, please let us know and please keep us. About this.
So there is a group in Japan who are working, I don't know where they are. But I know that they're starting to get involved. But I think similarly, Japan is going to be a really small partner, and it probably doesn't, it's probably fine for Japan to let everybody else figure problems out and then just follow it a bit.
But it would be good to
Yeah, make
connect
sure that the
connect
concept,
those signs.
know where it
with
is,
the network
and
people
yeah,
generate. Early as possible,
yes,
so nobody's surprised.
Thank you very much.
yeah.
Immigrants don't like to.
So send me an email. Did you get my email? Did you see my I think you can see the slides.
Yes, I will give you a name.
Yeah.
Well, after the concept, the A1 or whatever, and I just wanna know that if you wanna do the diversity between the LG1 network and for that capacity, so that so in the A1 area, and in the Asia area, the summer cable breaks are very over.
Yeah.
Yeah, right. And which means that if the traffic of the each country is very small, then it will be going to the same circuit.
Yeah.
So that's so we have to we should know that what kind of how much the capacity, the maximum of each region
Yeah.
will be taken care. So that is the one that we have to care. And for the safety net has the slightly from the home, but so it always it is sometimes breaks. And on Singapore it is very down. So that we get some backup. Before we get that situation, so that so the for the LHT project, so that it has to travel, so that during the Singapore and the Europe, so that we have three of them went down in the last year. So that it kind of prevents us the experiment right there. So that the cross running. So that I guess I had the previous avoid this, but you have to from now. So that is my point.
Yeah, that's very good comment, and I think we're working on that, right, it's you're working on it in the DNA and all that, and then it's working on that. And it's one of the reasons we need to understand. After this question. What is the expectation of some of the big consumers of the capacity like LHC, like SKA, a few others, right, that if we big plans, so that we can plan for which traffic goes, because we have seen in the early days of ANA, that when one link broke, all the 100 or the 70 gigs on that one link, was moved to all of it to the same other link that already had 50 gigs, and that doesn't fit, right? You need to have a plan in advance, where the traffic go, and how much traffic are you expecting to have, as in Simon and his team has come a long way on getting staff to also be involved. Doing that for ER, those sort of things, right, for ENA, and we'll be learning from each other with that. But that is really important, and that is one reason we need to make sure we keep in touch with people at SKA, so we know how much traffic to expect from Perth into Hong Kong or into Tokyo, or where it's going to go, so that we know that we can plan our emergency procedures so that it can take out. Otherwise, it will.
And it would be good in doing that to build in a tool there to be able to treat different communities differently.
Yes.
Yeah, this will help.
I personally reminded of that. So the thing, the challenge that we have in some way related to what happened.
And I guess the topic mentioned the policy involved for the each circuit, so you have to mention that.
Yeah, something true. Yeah, there's also some links that are bought for
Yes,
this
sir.
purpose.
Yeah.
No.
Okay, I think we're about at time. So thank you very much, everyone.
Well, yeah.
This is
But she's
useful and we see how it goes. Watch this space.
Irene,
Things may
you
creep a
and
little bit further still, but I think.
But I do think the important part is that we establish the
Jason?
concept.
Yeah.
We now know we should keep
the
it up
engineer.
once a year.
Yeah.
Very few things, know how much you have.
You don't know.
We, how much traffic we do.
Yes.
The more we can be in front of its development, the more we
Yeah,
Okay.
Thank you.
it's not yesterday.